Hello, Mr. Morrissey here with another maths video for you. This is my second in a series of videos exploring fractions. In the first one we looked at what a fraction is, and if you haven't watched that one yet, then maybe you should do so now before carrying on with this lesson. In this video we're going to look at adding fractions, and I'm going to ask you a big question that you should be able to answer confidently by the end of the lesson if you think carefully. Well, let's get started. Look at this example. Mo says 3/12 plus 5/12 is equal to 8/12. Mark says 3/12 plus 5/12 is equal to 8/24. Now, who do you agree with and why? Pause if you need to so you can think about that. Well, Mo is correct. 3/12 plus 5/12 is equal to 8/12. But why? Why is that the correct answer? Now, when I've taught this lesson to classes of children, they've generally said something along the lines of, oh, when you're adding fractions and the denominators are the same, you just add the numerators, the denominators don't change. And yes, that's true, but why? Why don't the denominators change? That's the big question we're looking at today. Why is it that when you're adding fractions and the denominators are the same, that the denominators don't change? Now, I'm sure you got some great ideas about that already, but we're going to use something called unitizing to help us answer the big question. Unitizing is when you're thinking really carefully about what you're counting, what units you're using. Unitizing. We're going to look at a few examples of this and then see how we can apply them to fractions. First example. What can you see here? 3 cupcakes. 3 cupcakes is the same as 3 lots of 1 cupcake, and 2 cupcakes is the same as 2 lots of 1 cupcake. Now, if we're adding these amounts, we can say 3 cupcakes plus 2 cupcakes is equal to 5 cupcakes, or 5 lots of 1 cupcake. Now, what are we counting here? What are the units? They're cupcakes. We're counting cupcakes. Next example. 4 cats is the same as, yes, you've guessed it, 4 lots of 1 cat. And 3 cats is the same as 3 lots of 1 cat. Now, if we're adding these amounts, we can say 4 cats plus 3 cats is equal to 7 cats, or 7 lots of 1 cat. What are we counting this time? What are the units? The units are cats. We are counting cats. Next example. What are you imagining here? Well, 5 kilograms is the same as 5 lots of 1 kilogram. And 1 kilogram is the same as 1 lot of 1 kilogram. And if we're adding these amounts, we can say 5 kilograms plus 1 kilogram is equal to 6 kilograms. Or 6 lots of 1 kilogram. What are we counting this time? What are the units? The units are kilograms. We're counting kilograms. Now, what's this got to do with fractions? Well, let's look at this example and see. 2/5 is the same as 2 lots of 1/5. And 3/5 is the same as 3 lots of 1/5. What are we counting this time? What are the units? The units are 1/5. We're counting 1/5. So this time, if we're adding these amounts, we can say 2 1/5 plus 3 1/5 is equal to 5 1/5, or 5/5. What about this example? 3 7s plus 2 7s. What are we counting this time? What are the units? They're 1/7. We're counting 1/7. We're counting maybe these, or you can think of it this way. This is 1/7 of the whole in bar model format. So this time I wonder if you can complete the number sentence yourself. Well, it's 3 1/7 plus 2 1/7 is equal to 5 1/7, or 5/7. You might think of it like this in bar model form. Can you see the 3 1/7ths? Can you see the 2 other 1/7ths? And can you see how altogether that's 5 1/7ths, 5/7 of the whole? Have a look at these questions. What's the same about them and what's different? Pause here if you need some time to think. The first one, 4 cakes plus 7 cakes is equal to 11 cakes. 4 kilometers plus 7 kilometers is equal to 11 kilometers. 4 pounds plus 7 pounds is equal to 11 pounds. 4 trillion plus 7 trillion is equal to 11 trillion. And 4 twelfths plus 7 twelfths is equal to 11 twelfths. Now, what's the same each time? Well, each time you're adding 4 and 7. 4 of something plus 7 of something to get 11 of something. And what's different? Well, the units are different each time. Another example for you. 3 cats plus 2 cats is equal to 5 bananas. Yeah, happy with that? Great, we'll move on. Well, you're not happy with that. You think I made a mistake? Hang on a second. I think you might be right. I think I did make a mistake. In fact, I think that answer is totally bananas. But why? Why is that answer so ridiculous? Well, we're counting cats, aren't we? So the answer has to be the total amount of cats we have. Can't be bananas. That's just bananas. We're ready to answer the big question. Do you remember it? Why, when we're adding fractions and the denominators are the same, do the denominators not change? Well, think about all the learning we've been doing and all the work in particular on unitizing and see if you can come up with a clear mathematical explanation of your own. Pause here and have a think. Here's my answer. The denominator tells you what you're counting, what units you're using. Now here we're counting 1/12ths, so the answer has to be all the 1/12ths that we have. I hope that makes sense. Now I've got 2 final questions I want to leave you with to get you thinking about the next steps on your fractions learning journey. Here's the first one. 3 cats plus 2 dogs is equal to what? How could you think about that? How could you answer it? I know. I could change these names so they're the same. So instead of 3 cats and 2 dogs, it could be 3 animals plus 2 animals is equal to 5 animals. Or 3 pets plus 2 pets is equal to 5 pets. Now what's this got to do with fractions? Well, when you're adding things with different names, you need to change the names so that they are the same. You need to change to a common name or a common denominator. Denominator means name. So that's why when you're adding fractions like this with different denominators, different units, you need to change the denominators so that you're counting the same thing. Last question, what about subtraction? How could you apply all the learning and thinking you've been doing about adding fractions to subtracting them? So for instance, Mo here is working out 5/12ths minus 3/12ths. Well, what's the answer? Why is that the answer? And how can we use unitizing to explain our thinking? I'm going to leave you with that. Well, that's it for this video. I hope you enjoyed it. I hope I made you think deeply, and I hope you feel you understand fractions a little bit more now. In the next fractions video, we'll be looking at how we can apply unitizing to improper fractions to help us understand them. Make sure you subscribe to my channel so you find out about all my latest videos as well. Take care and happy mathsing!